Hey Calculus kids, this is Dr. Callahan with week 5 Monday with semester 2 of AP Calculus AB. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. Okay, let's go ahead and create the assignment for your calculus class today for the hybrid kids. So today we're going to talk about week 5 Monday, AP Calc, semester 2. Instructions to view the assignment, watch the video, and then upload your assignment to the MS Team assignment tab for week 5 Monday. Keep in mind you guys have 2 links for this class. One is for the YouTube channel, the other one is for calculus. Make sure you guys are checking in with me, especially if you are doing this on a hybrid model. And our objective today is going to be finding the derivative. I know you're thinking like, what are we talking about derivatives again? But we're going to be doing derivatives and integration of natural logs. And the reason we kind of wait to the second semester, even though derivative is a first semester skill, is because of use substitution. You're going to be needing use substitution for derivatives, but use sub wasn't introduced last semester. So that's why we're kind of backtracking a little bit. All right, so with that said, the assignment is due by 3 p.m. Excuse me. 10 points. And I'm going to assign that. All right, so then with that said, this is a brand new week for your Math Excel. I'm going to make sure that you guys can take a look at this. Let's see. If you take a look over here for your Math Excel, week 5 is opened. It is going to be due at, and you know what, I just noticed that. Hold on a second. Week 4 is due by 8 o'clock, so let me go ahead and redo this one more time. Edit. Okay, fine. Let's try this one more time. Sorry, it's taking just a little bit of time to download this. Okay, well, you know what? Maybe we'll just go back to it later. But anyways, your week 5 is available. It is opened, so make sure you guys access that. So with that said, let's go ahead and just jump in to see what our today's assignment is going to be about. So this is the breakdown for today. We're going to talk about differentiation with natural logs, and we have 8 examples I'm going to go over with you guys. And with that said, take a look at the notes for today. This is your first page on week 5 Monday. I have my notes on log expressions and derivatives, whatnot. There are several different examples here that's typed up, 8 to be exact, so make sure you read that. Here's some of the theorems on logarithmic properties. That is a review for Algebra 2 honors. And then, of course, right here is a derivative of natural log. The derivative of L in x is just 1 over x, whereas the derivative of L in u means that it is something that will require the chain rule. It is 1 over u times u prime. So you have to find the derivative and multiply it to the 1 over u. Here are our 7 examples, not 8, 7 examples that we're going to go over in class. And so with that said, let's go ahead and proceed forward with this then. So everybody turn over to this page right here. And if you need a moment, you can go ahead and pause the video and make sure you are reading the notes and also the properties that we will probably be using. Get yourself acquainted with them. All right, so let's take a look at the very first one here. A is actually going to be a pretty easy one. So actually, let me change this a little bit. Okay. So we're going to start off with something easy. So the derivative of ln 2x. So in this situation, you will be using a u because the 2x does require a chain rule. So we're going to say let u be 2x. U prime is just going to be 2. You know the derivative of ln is going to be 1 over u times u prime. So that's going to be 1 over 2x times 2, which is just going to be 1 over x. And that is your answer. Now let's take a look at the second part right here. Okay, pause the video and give this one a try. You're going to say let u be, inside the parenthesis, x squared plus 1, u prime equals 2x. So what is the derivative of ln x squared plus 1 going to equal to? All right, let's go ahead and take a look at your answers. And this is what you should have. So pretty simple for the most part. It does, however, become a little bit more complicated as such with the second example over here. So let's go on to the next one. All right. So looking at this one here, you have an x times ln x. And no, hold on a second. That's not correct. Listen. Oh, you know what? Yeah, let's go back to this one. So with this one, looking at this, you do have a multiplication. You would have to use the product rule. So in which case, remember, f is going to be x, f prime equals 1, g is ln x, g prime is 1 over x. So the product rule is going to be f prime times g plus f times g prime. So if I replace this, it's going to be 1 times ln x, which is just ln x, plus f times g prime, which is really just 1. And so that is your answer right there. All right, let's take a look at D. With D, you're going to well, before I actually do that, you don't actually have a chain rule. You can just do it this way. We're going to bring that 3 down minus the 1. So I have a 3 ln x squared times the derivative of this chain. And what is the derivative of ln x? It's 1 over x. So afterwards, you just have to make this look a little bit better. So you have 3 1 over x ln x squared. And that is your answer. And really what you can do is you can go ahead and just move that 3 up. So it's 3 over x. All right, let's take a look at this one here. So the answer is going to be 1 over 2x plus 1. Pause the video and give it a try. So I provided you with the answers. You provide me with the steps. All right, so looking at this one here, another way of writing this is just going to be ln x plus 1 to the 1/2. So you could say let u be x plus 1, then your u prime, because I'm so used to doing the du's with u sub, but we're not doing du's, u prime is going to be just 1. So then if I were to replace this, I have the ln u to the 1/2, which I'm going to find the derivative of. So I'm going to bring the 1/2 down. So that's going to give me a 1/2 ln u to the negative 1/2 times the derivative of u prime, or actually just u prime. So then I would have a 1 right here. So then what's going to end up happening is I'm going to put the u sub back. So 2 times, let's go ahead and make this a little bit smaller, ln x plus 1 to the negative 1/2. Oh, you know what? I'm sorry. I made a little mistake here. Hold on a second. Take that back. Hold on. Okay, so looking at this right here, what's going to end up happening is I'm going to go ahead and move that 1/2 down. So I have 1 over 2 ln, and I have x plus 1, which this part right here is going to be u. So then that is going to give me a 1/2 ln times 1 over x plus 1, which then if I go ahead and replace this, it is going to be a 1 over 2x plus 2. And if you look at this right here, remember your derivative of ln u is equal to 1 over u times u prime. So when I go ahead and replace this, be careful with the ln u part, it's 1 over u, which is 1 over x plus 1 times u prime, and u prime, as we know, is just 1. But then don't forget the 1/2 there. So your 1/2 has to be distributed into the 1 over x plus 1. And this is your answer. All right, let's take a look at this one here. Okay, so with this one, because there is a fraction, let's maybe try to rewrite the ln, look at some of the properties that you can rewrite ln with. And I noticed that when you have the 2 right here, remember with the ln, you can go ahead and bring that to the very beginning. So I'm going to break this apart. There's a multiplication right there. So I could do ln x, change that multiplication to a plus, bring that square down to a 2, ln x squared plus 1. There's a division, which you change that to a subtraction, minus ln 2x to the third minus 1 to the 1/2. Okay, once you have this, you can go ahead and find the derivative of the ln's separately. Derivative of ln x is a 1 over x. Here, you're going to let u be x squared plus 1. U prime is 2x. So think of this as 2 ln u, okay? And so then what ends up happening here is, what is the derivative of ln u? It's 1 over u, which is x squared plus 1, times u prime, which is 2x. And if you want to clean this up a little bit, you have a 2 and a 2x right here, which gives you a 4x over x squared plus 1. Okay, then minus, here you go, you're going to do another u substitution here with a derivative. U is going to be 2x cubed minus 1. U prime is 6x. So looking at this part here, remember with the 1/2, you can always bring it to the front because it is with the ln u. So you have a 1/2, and then you're going to do the ln, because remember this is the ln u. Derivative of ln u is going to be 1 over u times u prime. So I'm going to go ahead and replace my u and u prime. U is going to be replaced with 2x to the third minus 1. u prime is going to be replaced with 6x. Now I want to clean this up a little bit. So 6 and 2 gives me a 3x. So that's going to be a 3x on top, 2x cubed minus 1. And this is your answer, you guys. That is it. So again, just a different strategy of utilizing this. All right, let's go ahead and go on to the next one. Okay, so I'm going to give you guys a moment for you to try this. Here is the answer, so pause the video and give it a try. Okay, so let's go ahead and take a look at this. First thing I would recommend doing is you want to go ahead and rewrite this from a cube root and a division sign. So I will rewrite it as, let's do ln x minus 1 over x plus 1 to the 1/3. So move from a radical form to an exponential form. Okay, so that's the first step. Then I see the power here. I could bring that down. So I have 1/3 ln, and just keep in mind that because there's a division sign, you can go ahead and do a ln x minus 1 minus ln x plus 1. And the 1/3 is to both terms here. All right, so then after that, let's proceed on with the derivative. You know, if you let u be x minus 1, u prime is just 1. So you're going to replace this with ln u. And what is the derivative of ln u? Remember, it's just me 1 over u times u prime. Now you're going to substitute the u and the u prime back into this. So u becomes an x minus 1. U prime is just the 1. So really, I don't even need to have anything there. Minus, now you're going to do the same thing with the second piece right here. U is going to be x plus 1. U prime is 1. And so this is a ln u. And remember, the derivative of ln u is 1 over u times u prime. But I'm going to replace the u with an x plus 1, u prime with a 1, but I don't need to have it at all. Okay, so at this point, you have two different fractions. My suggestion is you want to combine the two fractions into one. So guess what? They would have to have a common denominator. Your common denominator is going to be x minus 1 times x plus 1. So if I were to multiply this one with the x plus 1, I will have to multiply it top and bottom. Second fraction is x minus 1. Multiply that top and bottom. So then if I distribute that, the denominator is going to just have x minus 1 times x plus 1. In the numerator for the first fraction, you should have a 1 times x plus 1, so that's just an x plus 1. For the second numerator of the second fraction, 1 times x minus 1 is just x minus 1. But because you have a negative here, it's going to become a negative x and a positive 1. And then afterwards, you can go ahead and cancel the x's, which is going to leave you with a 1 over 3 times 1 over, actually 2, because 1 plus 1 is 2, x minus 1 times x plus 1. And if you go ahead and combine this together, 1 times 2 gives me a 2, 3 times x minus 1 times x plus 1. You can actually FOIL this, which will then give you x squared minus 1. And that's why, you guys, this is going to be your answer. All right, let's go on to the next part of this. So up to this point, we have completed the following. We've done this part, this part. Let's go on to number 6. So I'm going to have you guys pause the video and take a look at this. Would you be able to find the derivative of this given the formula and the answer? So pause the video and give that a try. Okay, so let's take a look at this then. So with this one, your u is going to be secant x plus tangent x. Your u prime is a derivative of secant is going to be secant x tangent x plus the derivative tangent, which is going to be secant squared x. So then if I were to go ahead and replace this with just a ln u, you know f prime of x is going to be 1 over u times u prime. So then I'm going to replace the u in this situation with secant x tangent x. And I'm going to replace the u prime here, which is in the numerator, with secant x tangent x plus secant squared x. Now, as I'm looking at this, notice what can you cancel? That's going to be from top and bottom. I know if the denominator, I have a secant x tangent x, or excuse me, I have a plus. I forgot the plus right there. I know in the numerator, I do have that as well, and I can probably rewrite this to a secant squared x plus secant x tangent x. So then I can factor this and go one step further to ensure that in order for me to get the secant x plus tangent x, I could factor out a secant x. So then as you look at this here, the secant x plus tangent x cancels. And then what you're left with is f prime of x is equal to just secant x. And that is your answer. All right, let's go ahead and take a look at this one. This will be the last one that we go over. It's also kind of a long and tedious one, but I think it's good to practice with some of the more difficult questions here. All right, so looking at this here, first thing I would expect you guys to maybe try to do is rewrite this in expanded form. I see a square there, so maybe bring that down. So you have a 2 ln x minus 2. And then I have here in exponential, a radical form, put that into an exponential form. And because there's a division, put a minus 1/2 ln x squared plus 1. Okay, so then let's go ahead and move forward with solving for this. So if I let u be x minus 2, u prime equals 1, and remembering the replaces with the ln u. So then when I find the derivative of this, I have 2, derivative of ln u is 1 over u times u prime. But then remember, you're going to go ahead and replace the u with x minus 2. And you're going to replace the u prime with a 1, so that doesn't really change much of it. Now let's take a look at the second second u substitution here. So if you let u be x squared plus 1, u prime is going to be a 2x, and remember this is going to be ln u. So then ln u, remember, is just 1 over u times u prime. So let's replace the u with the x squared plus 1 and the u prime with a 2x. And looking at this here, this 2 cancels. And then I am left with a 2 over x minus 2 minus 1 over x squared plus 1. So as always with, a fraction, you want to have the common denominator by combining the 2 fractions. So your common denominator is going to be an x minus 2 times x squared plus 1. So I'm going to multiply the first fraction by x squared plus 1, top and bottom. Second fraction, multiply by x minus 2, top and bottom. So then I know that my denominator here is going to be a x minus 2 times x squared plus 1. I'm just going to try to maybe fix the numerator a little bit. Distribute the first fraction. You have a 2x squared plus 1. Numerator of the second fraction, don't forget your negative, is a negative x plus 2. Now combining these together, I have a 2x squared minus x. 1 plus 2 gives me a 3. So at this point, this is as far as you can go. So you can go ahead and leave it like this. I do want to know if maybe it's a possibility for me to maybe factor this out and see perhaps if I can cancel something. So going back to Algebra 2 honors, you can factor this whichever way you want. Let's do 2x on x, 3, 1. Make that negative and negative. And actually, there's no way I can do it because this is going to give me a negative 2x minus 3x. Added together, it's not going to give me a 5x. And even if I change the combination of this, it's not going to be factorable. So, at this point, I can just leave it like this and just be content with it. So this is my answer at this point. But it never hurts to try and see if there's a possibility of factoring this. Now, on the other hand, if the middle number is a negative 5x, then I will be able to factor this. And my hope was that I was able to cancel something here, but in this case, it didn't work out. All right, you guys, that is basically it. Now you know how to do U sub with derivatives of ln. I hope you guys have a wonderful evening, and I'll see you guys next time. Take care.